In this video, we shall discuss on the characteristics function of a random variable for the Bernoulli distribution. We are also to obtain the expectation and the variance for the characteristics function of Bernoulli distribution. The first thing to do is to write out the characteristics function for the Bernoulli distribution, which is Q plus P E I T. So this is the characteristics function for the Bernoulli distribution. We obtain the expectation first before we obtain the variance for the Bernoulli distribution. For more on this topic, you need to subscribe to this channel. So to obtain the expectation of x, we take the first derivative of the characteristics function at t, which is equal to, so we have to differentiate this. And if we take the first derivative of this Bernoulli distribution, the first thing what we get is p, then the imaginary unit exponential I t, where I is the imaginary unit. Now, we say at t equal to 0. At t equal to 0, we have our first derivative equal to 0. It means anywhere we see t, we put 0. So we have pi exponential I 0. Of course, from indices, we know that exponential I 0 is equal to exponential 0, and anything raised to the power of 0 is equal to 1. So this is equal to 1. It means anywhere we see exponential I 0, we can put 1 there. So we can write our characteristics function to be equal to pi multiplied by 1, which is equal to pi. Therefore, our first derivative is equal to pi. Now, we can now write the expected value of x. The expectation of x can now be written as is negative I, our characteristics function, is equal to this. Because of this negative sign, we put it here, negative I multiplied by pi. So our expected value of x is equal to negative I squared multiplied by p. We said what? I squared is equal to negative 1. It then means that our expected value of x is equal to negative into negative 1 multiplied by p. We can now write our expected value of x. So our expected value of x is p, because negative sign will cancel negative sign, and 1 multiplied by p will give us what? P. So the expected value of x is p. The next thing to look for is the expected value of x squared, and this will enable us get the variance of the Bernoulli distribution. So we move over to this side of the board. For more on this topic, you need to subscribe to this channel. When I say to obtain the expected value of x squared, it means you have to look for the second derivative of the characteristics function. Now, what did we get as the first derivative of our characteristics function? What did we get? We have to write it out first. What we got, we recall that So you say recall that the first derivative for our characteristics function at t is we got p I exponential it. This is what we got. So what we'll do now is to differentiate this the second time. It then means that the second derivative is equal to t. That means we are differentiating with respect to t. The second derivative will give us this. Our imaginary part will now turn to I squared, because if we differentiate this function, we will have an imaginary part that will come here, which is the characteristic function. So we now have exponential I t. The next thing to say is at t to be equal to 0, so that we can eliminate this function to find our expected value of x squared. So we also move over to the other side. For more on this topic, you need to subscribe to this channel. We should not also forget that we got our expectation of x to be p. We got our expectation of x to be p. So at p is equal to 0, we can write our derivative as p I squared exponential I 0. Of course, we know that, but from indices we have that I naught is equal to exponential 0, and anything raised to the power of 0 is equal to 1. So this is what we get. So it then means that our second derivative of the characteristics function will now give us pi squared. Now we can now write the expected value of x squared. So the expected value of x squared is equal to negative I squared, our characteristics function, which is equal to, because of this negative sign, we have negative I squared and p. Of course, we should recall that I squared is equal to negative 1. So our expected value of x squared is equal to negative into negative 1 and p. So it then means that our expected value of x squared is equal to same p. So we have, for the expected value of x for the characteristics function of the Bernoulli distribution, we have p. While the expected value of x squared for the characteristics function of the Bernoulli distribution, we have p. The next thing to do is for we to look for the variance. The next thing to do is to look for the variance. So we come over to this side. We know that the variance of x is equal to the expected value of x squared minus the expected value of x all squared. And if we recall, we know that the expected value of x squared is equal to p, while the expected value of x is also equal to p for the characteristics function of the Bernoulli distribution. Now, our variance can now be written as the expected value of x squared can now be written as p minus p all squared. So our variance is equal to p minus p squared. Of course, we can also open this to give us P to be equal to 1 minus P. But from probability theory, we know that if Q plus P is equal to 1, it implies that Q is equal to 1 minus P. So we can now write the variance properly, our variance of X. Our variance of X now will be equal to P Q. Therefore, our variance for the characteristics function of the Bernoulli distribution will give us PQ. So we have PQ for the variance. We also have our expected value of x squared to the P, and the expected value of x will also be P. So this is how to compute or how to derive the characteristics function for the Bernoulli distribution, the expected value and the variance for the Bernoulli distribution. This is how we can compute it. For more on this topic, you need to subscribe to this channel.